Okay, this is chapter 18, the environment and human health, which is very fitting for what the world is going through right now with COVID. Here are our learning objectives. We'll first start about a different virus, the Zika virus. You're probably familiar with this. It was discovered back in the 1940s, soon after found in humans. It's vectored or carried by a mosquito. In 2007, it kind of reemerged in the Pacific Islands and started to become of an interest in 2015 and 2016. Um, in 2016 of November, the World Health Organization recommended efforts be escalated into a sustained strategic response, and we'll talk about that. Some of the symptoms of the Zika virus are pretty mild, just a low-grade fever and achiness. But the big problem is if it were to infect pregnant women, because their unborn children can be born with microcephaly, that can occur with infection during pregnancy, and microcephaly is an abnormally small brain. So the WHO's 5 strategic objectives, which is how they dealt with the Zika virus and probably similar with what they're doing with COVID right now. These are the first ones on your notes, are detection, prevention, care and support, research, and coordination. So this is what a baby born with microcephaly would look like, an abnormally small shaped brain and skull. So this would lead to neurological problems for the child with a much shorter life expectancy. Here's with the predictions of increasing temperature, this map predicts the likely distribution of the mosquitoes into the contagious United States based on suitability of habitat. If you remember, this book was written in 2017, so the Zika virus would have been fresh in the editor's minds. So that's why they started the chapter with this virus. Aerial spraying and unintended consequences. These planes are spraying pesticides to try to get rid of the Zika mosquitoes in South Carolina, but an unintended consequence was that they also were killing off the honeybees. So this aerial spraying soon stopped. Measuring public health, there's population level statistics. The life expectancy at birth is defined as the average number of years that a newborn child is likely to live. That's about 70 plus years worldwide, which is a huge increase from the life expectancy if you were born in 1950, you'd probably only have a life expectancy of about 46 years. The mortality rate also measures the health of the community, and the infant mortality rate, or it could also be known as the neonatal mortality rate, is the percentage of infants that die before age 1. Worldwide, this is about 3.8%. Obviously, that's much higher in developing countries. But again, in 1950, it was about 15%. So that just means that 15% of all infants being born would die before the age of 1. Here are worldwide causes of death. So worldwide, regardless of income, heart attack and stroke and obstructive lung diseases are the big ones. Pneumonia, diarrheal diseases are also more common. And this graph kind of gives you a breakdown of how wealth and the access to clean water and medicinal services would kind of relate into those causes of death. So high income countries, heart attack, stroke, Alzheimer's, dementia, those are still the big ones in high income countries, but in low income countries it changes. Where we get a lot of the infectious diseases are in much higher categories. That's just because those infectious diseases are spread and due to lack of sanitation, lack of infrastructure, lack of hospitals and access to medical care. So HIV/AIDS is a big one in low-income countries. You'll see more cancers in high-income countries. It could just be because people are living longer in high-income countries, and eventually everyone will die of something. And cancers, cancer doesn't discriminate, so anyone could get that. One thing, the heart attack and stroke are often due to lack of exercise, lack of nutrition in high income countries. So, not eating well, not exercising. So that's interesting that heart attack and stroke are still the highest there. So if we were in class together, we would take a look at California's death rate and how it compares to the United States, and how the US infant mortality rate compares to California. So you can see here how the US ranks in the top 10% globally for the death and infant mortality rate. So that means the top 10, but the top 10 lowest, which makes sense because we're an extremely developed country where most of us, not all, have access to healthcare. We can go to the hospital when we need to. As we look at public health, we look at the hazards and risks associated that can attack us. We group them into whether they're physical, chemical, biological, and cultural. And the risks posed by environmental hazards may be immediate, so that's in your notes, or delayed. And then number 2 under hazards and health lists those 4 categories. A latent consequence is anything with a delayed effect. So some effects of these hazards are immediate, while others can be delayed. And one of the latent effects is exposure to radiation. So in some sort of maybe biological or chemical hazard or risk, years later, people could still be affected by the radiation. Here are environmental hazards. So tornadoes in Kansas are an example of a physical hazard. Air pollution is a chemical hazard. Measles and other infectious diseases, we categorize those in biological hazards. And cigarette smoke is what we would categorize as a cultural hazard. That and vaping, maybe drinking alcohol, anything that is culturally acceptable but is probably not very good for your health. Risk perception and reality. Human perceptions of risk often differ from the reality of it, which just means that how we perceive a problem or a hazard might be different from the actual reality of it. And that can go in both ways. We could perceive it as being much more dangerous or much less dangerous than it is. So key factors can influence risk perception. The myth of zero risk. This is important to note because it's virtually impossible to reduce the risk of most natural and human-caused hazards to zero. So that just means that everything has some sort of risk to it. Public awareness. Publicity has a significant effect on the perceptions of the degree of risk posed by hazards. This is extremely true. Risk trade-offs. The benefits of reducing the risk posed by one hazard are often considered in isolation from other related risks, and these are called risk trade-offs. And then control. People generally perceive a risk to be lower if they feel they have some level of control over that risk. So a lot of people drive their cars everywhere. They think they'll be totally fine, but in your notes it says each year in the US, approximately 40,000 people die in auto collisions, which, I mean, that's pretty bad. So be safe out there, especially in LA. Risk in time. People tend to view latent risk as being less serious than immediate risks, even if they are equal or greater. This is true if you smoke cigarettes. I always tell my students smoking is just that, and eating healthy and exercising. Smoking just lowers your life expectancy tremendously. It does so much bad for you. But people don't really think about that, and it's hard to think about it when you're in the moment and you need that fix. Physical hazards. Geological hazards include earthquakes, tsunamis, volcanoes, weather hazards, hurricanes, typhoons, floods, fire in the environment, wildfires. So these are all examples of physical hazards. We categorize they can be geological, weather, and then fire. This is the earthquake magnitude and intensity. The Richter magnitude scale expresses the energy released during an earthquake, so that's how we get those numbers. The earthquake intensity scale indicates its effect on people and buildings. So the 2011 earthquake centered off the east coast of Japan that caused huge tsunamis had a magnitude of about 9 and an intensity of 10. Earthquakes have been on the rise in kind of unique places such as Oklahoma, and they think that's due to oil drilling activities, which is interesting. And it tells us maybe we shouldn't be messing with the earth too much. Here's the geography of earthquake hazards. We talked a little bit about this, how earthquakes will normally occur in places where tectonic plates are sliding past each other. So we live near one of those tectonic plates in Southern California. You can see the tectonic plate boundaries in this graph on green and see where the high and very high earthquake hazards are located along those tectonic plate boundaries. Here's a look at a tale of two cities. In 2010, I remember this because I was graduating college, and I was going to go to the DR, which is right across from Haiti, to teach, but a magnitude 7.0 earthquake in Haiti devastated Port-au-Prince, and you can see here their infrastructure was just demolished and decimated, and that's the picture on the left. In B, that same year, a magnitude 7.2, which is just over 7, occurred near Mexicali, Mexico, and that resulted in damage and loss of human life that were modest in comparison. So that just shows that building codes are much more strict in Mexico and the US than in places like Haiti. And those building codes and infrastructure can greatly help the impacts of when an earthquake were to hit. This is how a tsunami is formed. So if there's a fault thrust or kind of a brushing up of faults against each other in the ocean, water will become displaced, and you won't notice it much in the middle of the ocean, but the wavelength and the wave height will increase as waves move closer to shore. This can cause a huge tsunami. This is the 2011 tsunami off of Japan. So where that earthquake occurred, it caused this huge tsunami with waves reportedly as high as 40 meters, which is over 130 feet. The economic cost of this tsunami has exceeded $235 billion, making it the costliest natural disaster ever, much more than any hurricane, any fire. This has been the most costly natural disaster ever. Here are hurricane and typhoon tracks. So these are big tropical storms. Again, they're associated with wind patterns and how the earth turns and where the currents are. So these powerful storms, you can see category 3, 4s, and 5s most often affect the Caribbean, Eastern North America, and Eastern Asia. Here's a typhoon in Myanmar before and after a powerful storm in 2008, and you can just see how extensive clearing of land in the river floodplain, which are the beige color areas in photograph A, magnified the extent of flooding and loss of human life. So those beige colored areas of land were probably cleared for agricultural purposes, or they cleared their forests, but because they did that, then when there was a tropical storm, it just kind of filled up that floodplain because there was nowhere for the water to seep into the ground. Preparedness matters. So this is people walking through flooded streets in Houston just days after Hurricane Harvey in 2017. Harvey caused as much destruction as Katrina did in 2005, yet the Texas hurricane was much less deadly because people were more prepared for it. They probably learned from what happened in Katrina in 2005. Over 1,800 people died in Katrina, but only 100 people died in Harvey, even though it was a much more serious hurricane. Here are deaths from extreme temperatures, which is kind of interesting to note. It kind of surprised me that more people will die in extreme cold than extreme heat, which I guess makes sense. And these extreme cold deaths will happen in places that are a little farther north, northern China. Italy was interesting to me. When you see these graphs, you always have to be, leery of, everything. You should be a skeptic of everything, which is what I tell you, but extreme deaths, is this including homeless people who don't have access to a home. So, because I think Italy was one that's interesting that has high cases of extreme death in there for moderate cold. Here's a dangerous trend. U.S. wildfires are increasing in number and consuming more and more acres of land each year. This is showing a picture of hundreds of homes in a neighborhood in Santa Rosa, California, and how they were destroyed in 2017. And just showing how fires are increasing. Again, why is that? Is it due to human activity starting these fires? Is it due to more people living, building homes near forests? Is it, just due to more lightning strikes? Is it due to more brush and undercover because forests aren't being cleared? So then we'll talk about chemical hazards. Toxicology is the scientific discipline that studies chemical poisons or toxins and their effects on human health. I studied chemistry, and in grad school, I studied toxicology a lot. So I just include a couple of these notes because it's kind of near and dear to me, and it's things that you might read about if you ever hear of some sort of chemical agent being used. You should know some of these terms. So the dose response curve shows the relationship between increasing dosages of a chemical and some measure of health. The toxicity threshold refers to the dose of something above which there's a measurable decline in the health. So toxicity threshold is the absolute highest you should be exposed to before it would start to affect your health. And then the median lethal dose, or LD50, is the dose at which 50% of an exposed population would be killed. So that would be the dose, if you were to give this lethal dose to everyone, 50% of everyone would die. These exposures, acute exposure is the contact that occurs only once for a short time, and chronic exposure is contact with the chemical for periods of weeks, months, or years. So the toxicity threshold is the dose that produces a measurable impact on survival. As the dose of a toxin is increased, the number of individuals affected by it increases. The median lethal dose, or LD50, is the amount of a chemical required to kill half of the individuals in the population. Here are an individual's sensitivity to a toxin. It's influenced by so many factors. So how sensitive you are to some sort of chemical agent or toxin, that can be based on your health, your gender, your age, your socioeconomic status, or any sort of genetic difference that is just ingrained in you in your genetics. Human vulnerability to toxins, it can be affected on various factors, which I just talked about: your genetic makeup, environmental causes, where you live, how much access you have had to healthcare in the past, your age, and your health. The toxin transport and fate, the impact of certain toxins depends on movement through the environment, their persistence, the volatility, the solubility in water, the uptake and fate in other organisms, and persistent organic compounds. Bioaccumulation and body burden are what I will focus your attention on. Bioaccumulation refers to the process by which chemicals are stored in the tissue of organisms, and that is number 4 under your notes, under toxin, trait, and fate, transport and fate. And then the body burden is number 6. That refers to the total amount of a chemical present in the tissues of an organism. Biomagnification, which is given for you in bold, number 5 on your notes, that's the process by which the concentration of a toxin can increase at each higher level of a food web. And we talked a little bit about that when we were studying food webs, how if little organisms are feeding on a toxin or an oil spill, it really will affect the entire food chain, but just be magnified as larger animals keep eating the smaller ones below it. Persistent organic pollutants, toxicologists designate particularly long-lived and widely dispersed organic chemicals as POPs. Here are the dirty dozen. These are 12 persistent organic pollutants that are among the most troublesome chemical hazards to human health. 10 of these chemicals are produced to kill fungi or insects. So 10 of these are just insecticides, which is kind of scary to think about because we probably use insecticides a lot, especially around here. So just be careful with those. Here's a little tiny dust mite. Doesn't that look pleasant? This is a common allergen. It's common in carpets and upholstery, which causes allergic reactions in many people. So it's one reason to maybe not put carpet in your house. I don't know, but not very pleasant, a little dust mite. Declining sperm count. So this shows 101 studies that have been done since 1934. And researchers have noticed what appears to be a slight decline in human sperm production, and they speculate that this may be due to increasing amounts of endocrine disruptors, which are toxins that can be found in the environment, usually due to medications that people are taking. But they also know that this data is kind of scattered, so maybe it's not a very slight decline, but this could be Again, another example of an effect of human health due to some sort of toxin, an endocrine disruptor. In 2014, 12 scientists published that newborns um, were being exposed to BPA in their bottles, which is a toxin found in plastic. Critics argued this study was flawed because they were only giving extremely high doses of BPA to rats or testing animals, and they didn't notice a risk if BPA was given to the rats at a much lower dose. However, even if you think that BPA can maybe sort of cause a risk, would you still buy plastic water that contained BPA? And then how does that change if you know that why do infants get special attention? And that's because usually children do. So I would probably never want to give my kid a bottle with BPA, even if there wasn't a significant risk. The fact that they found any makes you then scared of it. Toxin testing and regulation. This is a little interesting how they can test for toxins or if a substance is toxic. This is hard to do because you can only test on animals in the laboratory setting. And if you start to test on humans, that contains both ethical and practical challenges. The EPA is charged to monitor over 75,000 industrial chemicals, and most of these chemicals are assumed to be non-toxic until proved otherwise. So basically, you're innocent until you're proven guilty in the toxin realm. So there's two kind of ideas of testing and how much testing is enough. If you have two products and one is maybe toxic, the other isn't. The one way of kind of testing for it is that it's just innocent until it's proven guilty. So kind of much later in the process, it will become banned as people start to use it and realize maybe this isn't too good for us. There's a more precautionary principle approach where there's rigorous testing at the beginning stages before it's brought to the market. Again, that's probably the best way to do it, but you're still going to have to test somehow on humans. Maybe you make it voluntary and you give money. I think you can do that for some makeup products, can't you? You can get testing on these makeup products to see if it causes a reaction and they'll give you money. So you voluntarily kind of sign your life over. So how much testing is enough? That's one thing that the EPA has to go through. The Flint water crisis, you might have heard of this in 2014. In 2014, Michigan switched its water supply from Lake Huron, which is one of the Great Lakes, to the Flint River. The Flint River had suffered decades of industrial pollution, and high levels were detected in the water quality that it was being given to its residents. They actually discovered that the lead levels were coming from the corroded pipes that were carrying the water from the river to these homes. Data and findings from scientists empowered residents to demand changes. So here's what the Flint River looks like. It's undergone remediation, so the water is cleaner now, but it still contains some pollutants. The concentration of lead in the river was not high, but again, this water flowed through lead pipes. That's where it corroded them, and this resulted in high levels of lead in water delivered to homes and businesses. Children are especially susceptible to the effects of lead, and in the Flint, Michigan, as many as 12,000 kids were affected under the age of 6 by high levels of lead during the crisis. High levels of lead during developmental growth can cause really bad neurological damage to kids' brains. They can become autistic and things like that. Here's the scientists who kind of led the Flint water crisis study, taking samples from over 5,000 Flint homes, and they found that it exceeded the EPA standard, so kind of scary. Then we'll move on to biological hazards, and this is where there will be a couple more things in your notes here. Environmental factors influence the populations of the organisms that cause disease as well as those that spread disease. Infections are caused by pathogens, which can be viruses, bacteria, protozoa, fungi, or multicellular parasites that invade host organisms. And the extent to which a pathogen impairs the growth and reproduction of its host is called its virulence. And then we talk about anthropognosis or zoonosis. Anthropognosis is a disease only in humans. That's number 3 in your notes. And a disease that's shared by animal and humans, such as the flu, pig flu, swine flu, is called a zoonosis. So anthropognosis, the direct transmission is human to human. They may be transmitted directly or indirectly by an animal called a vector or in contaminated water or food, but they will only affect humans as the primary host. Whereas zoonosis, these are diseases shared between humans and other animals, and these may be transmitted directly or indirectly through animal vectors. Respiratory diseases include the influenza. So the Spanish flu happened almost 100 years ago, which is kind of scary. You think about viruses like this come around every 100 years. In 1918. And then another strain of flu, the avian flu, the bird flu, and the pig flu, the swine flu. You probably remember hearing those. So we have respiratory diseases and then diarrheal diseases, which are most from poor sanitation, polluted water. In diarrhea diseases, most die from dehydration. Again, this is spread through lack of sanitation and poor water quality. So these are cholera. Cryptosporidium is another diarrheal disease. Perception of disease. This chart shows and compares several diseases, and it shows the number of cases worldwide per year, as well as the number of deaths per year. Note that diseases and our perception of them can vary greatly. Here's a look at the bird flu. This is a micrograph. It shows the virus in gold, and it causes the avian flu in kidney cells, which were in green. The lab worker on the right is just testing for the virus, the presence of that virus. You can see his protective covering there. Cholera and climate. The incidence of cholera in Bangladesh, corrected here for natural seasonal variation, rises and falls in association with changes in the surface temperature of the sea. So the increase in cholera associated with warmer water was likely due to flooding during El Nino events. Rehydration therapy. So in most diarrheal diseases, everyone dies of dehydration, which can be fatal, especially in infants. And this is a danger that mothers without education don't know about. So they'll try to withhold water from their children, fearing too much liquid is the issue. And public education in regard to oral treatment with relatively simple rehydration fluids containing sugar and salts now can save thousands of lives. And so we call that rehydration therapy. Bloodborne diseases. This includes HIV, malaria, which is transmitted by mosquitoes. HIV and AIDS is acquired by sexual contact, or in the case of drug users, sharing needles. And that's usually a popular one and a really scary one that's always going on. Evolutionary change and the war against pathogen. Co-evolution between pathogens and their human host tends to diminish disease severity, and antibiotics and vaccines are our best weapons in the war against pathogens. So these are your notes. So coevolution is number 1 under evolutionary change, and then A and B, antibiotics are used to fight bacterial infection. So an antibiotic is something that inhibits the growth of microorganisms. So antibiotics can infect bacterial infections such as TB, tuberculosis, pneumonia, or diarrhea. Over time, though, through evolution by natural selection, some bacterial strains can become antibiotic resistant. And letter B talks about vaccines. Vaccines can fight viral infections. So a virus cannot be fought with an antibiotic. Another weapon is needed, and that's called a vaccine. And that a vaccine usually contains dead or non-harmful particles produced from a virus that can be used to stimulate a person's immune system. And vaccines can prevent the spread of disease through the population. So this is a look at the life cycle of a malaria parasite. It infects your liver cells and then the red blood cells, which will burst, releasing more parasites into the bloodstream, vectored by mosquitoes. A natural defense against malaria, an indigenous people in the Andes Mountains discovered that the bark of this tree provided resistance to malaria. So scientists learned that what chemical was involved in it, and then it gave this bark the medicinal property. This is what I just talked about. Sorry, I was ahead of myself. But coevolution, this just is showing between the pathogen and the host, it tends to diminish disease severity. But coevolution can occur where antibiotics can become resistant or to some bacterial infections, and vaccines will fight viral infections. This is showing the rise of antibiotic resistance. Over time, many bacteria are becoming more and more resistant to antibiotics. Vaccine preventable outbreaks. This shows outbreaks within the world that would have been prevented if everyone had this herd immunity buffer of vaccination. Ebola. So Ebola was a big disease back in 2014 that several African nations were dealing with rapidly. The spread of it was a diarrheal disease. It included vomiting, diarrhea, bloody gums, and ultimately organ failure. By late 2016, the Ebola outbreak was contained. The one sad thing about the Ebola outbreak is that not a lot of pharmaceutical companies were interested in investing money into it because it was occurring in low-income developing countries. But it was an incredibly scary disease because if you got it, you most likely died from it. But it was a diarrheal disease. You died of dehydration, and it spread through unsanitary conditions, lack of water. Here's Ebola's death toll and just showing how it spread extremely quickly within 12 months throughout these countries in Northern Africa, West and Northern Africa. This is showing when you're working with infectious diseases what a healthcare worker looks like. It's a lot more complex than a typical medical setting. You have to wear the surgical cap, the medical mask, the respirator, overalls, apron, boots, goggles, and double gloves. Environmental change and human health, the intimate and complex connections between our environment and our health are compelling reminders of the need to sustain key ecosystem processes and services. But with Earth's environment rapidly changing in ways that are affecting these ecosystems, human populations increase, so the risks associated with many physical, chemical, and biological hazards are also increasing. And this usually happens in urban areas. In many parts of the world, the negative impacts of air and water pollution are also increasing, especially asthma. They think asthma is related. The high increases of asthma, they think, are related to just poor air quality. More people are living in cities where air pollution is bad. This is a look at bats showing a deadly passenger. It's the vector known to carry the Ebola virus, shown in the smaller picture underneath. This is the increase of asthma on the rise. Why is asthma increasing in both kids and adults? And they think it's just because due to diminishing air quality in many regions. Here's the life cycle of another parasite. Freshwater snails are the host for this parasite, and poor sanitation and abundant habitat for snails maintain the prevalence of this disease worldwide. Landscape change and climate change can also affect human health, because when you alter the habitats of many of these animals that are disease vectors or share diseases with humans, then they increase the frequency of some of these diseases when they're more in contact with humans. Climate change can affect, if global warming is affecting these habitats, then that could allow disease organisms and agents to expand their range. So this is your last couple of notes: altered landscapes and global warming. This is showing in one last example the geography of Lyme disease. Lyme disease is spread by the vector, the deer tick, which is that little tiny animal. It gets embedded in your skin and sucks your blood, and it's really hard to get them out. So I just remember growing up as a kid in the Midwest, you'd always have to check yourself for ticks if you were out in the woods. So why is it happening? Probably because more people are living in those areas, so they're altering the habitats of these ticks. A disease on the increase of Lyme disease, again spread by ticks. And this is showing climate change and prevalence of dengue fever. However, the past several decades, warmer and wetter conditions in Mexico have provided favorable habitat for the mosquito that can transmit the dengue fever. We'll finish with that, guys. I hope you guys are all doing well.